So this is question 3 in our introduction to Hess's law calculations. This question is more like a question you would get on a Leaving Cert paper. So it says calculate the heat of the following reaction using the given data. In a question like this, you're always looking for the word calculate and what happens comes after it, because that is telling you what your top line is. The other giveaway that this is a top line is that it is not followed by delta H is equal to some value. So when those things are missing, this is your bottom line. So occasionally they will put this in, and that is not the bottom line. So you're always looking for the calculate and then an equation if it's there, or the words that come after it so that you can write the equation. Now to do this, we're going to use heat of formation of carbon monoxide, water, methanoic acid. And this word respectively at the end, that is telling you that this is the value for carbon monoxide. They're going to go in sequence. This is water and this is methanoic acid. Now, for this particular question, it's different to the first two in that we are going to be finding a heat of reaction. We could be finding a heat of combustion, and we're doing it from heat of formation data. So our Hess's law diagram is going to be a little bit different. So we follow our instructions. The first thing we have to do is write our top line. So so that is our top line. We then want to write balanced reactants for formation for all elements on the right hand side of the arrow. So I'm looking now particularly just here. We could do it from the right hand side, it doesn't matter. Heat of formation, we know, is the heat change when 1 mole of a substance is formed from its elements in their standard states. So this time around our arrow is going to go up. And to make methanoic acid, there's 2 H's, so the standard state for hydrogen is H2. There is 1 carbon, and there's 2 O's, and the standard state for oxygen is O2. We could do it similarly from this right-hand side, it wouldn't matter. Now, we have 1 HCOOH, and the value up here in our question was minus 424.7. We then have a look here. So our arrow is going to go up because it's a heat of formation, and it tells us for carbon monoxide we only have 1 carbon monoxide in our equation, so it's going to be 1 by minus 111. And then finally for heat of formation of water, and again we only have 1 water, so it's going to be 1 by minus 285.8. Okay, so we've done all of this. We've looked at our other components. We've labelled their up arrows correctly. And now we've got to figure out how we write our Hess's law formula. So again, we're looking at matching up the directions of the arrows. So these 2 arrows are the same. So they're going to be on the left-hand side of our equals, whereas these 2 arrows are going in a different direction. That's going to be on our right-hand side. So we have, we have delta H plus 1 by minus 424.7 is equal to 1 by minus 111 plus 1 by minus 285.8. As I say, normally we'd just rearrange and solve, but to make sure we get the sign right, we're going to solve this portion here for ourselves. So we're going to rewrite. I have a 1 by minus 424.7, but a plus by a minus is going to make this minus 424.7 is equal to, just rewrite out everything. I am a big fan in writing things and rewriting if you need to, and you just make sure that you're using the right number. You have less chance of making mistakes. To get rid of this minus 424, or to put it to the other side, we have to add it to both sides of the equation. And when we have done that, we can now just solve for delta H. And you plug it into your calculator the way it is looking at you now, brackets and everything, so you can't make any mistakes. and when you're done, it should be plus 27.9 kilojoules per mole.